Hello, I'm Michael Wybrow. In this video, I want to talk to you about another type of data storage, and that is property lists. And as part of that, I'm going to talk to you about Codable, which is something very useful both for property lists and also for some of the topics we'll cover next week. So what are property lists? Basically, they're just XML files, and you can store things like user settings and small bits of data. These are widely used in Xcode, for example, so things like storyboards are actually stored in XML format, and some of the other app settings are stored as property lists too. And you can store various objects, and these are things like NS data, NS date, NS number, NS string, NS array, NS dictionary. Okay, you're probably looking at this and going NS number or NS string. I know string and I know array and I know dictionary. What is NS array or NS dictionary? So NS is a namespace, but that's not what NS stands for. NS here stands for next step, and next step was a company that was acquired by Apple when Steve Jobs returned to Apple, and they had a set of frameworks called Next Step that were designed for writing desktop apps, and some of those have made their way into iOS and macOS. And before Swift came along and everyone was using Objective-C for writing iOS apps, all of the types that were used all use this NS prefix at the beginning of them. So how we use them is they exist and they're still available from Swift, but we typically just use the standard Swift types like array or dictionary or string. But you can convert one into the other, and there's certain parts of the iOS frameworks that do require you to use these NS types, and property lists are one of them. Okay, so let's have a look at an example of how we would save data into a property list. So we basically write, say, an NS dictionary into a file and put it in the app's document directory. So every iOS app has a document directory, and there's different types of directories. As I said in my previous video, there's a sort of cache directory, there's a document directory. You can put temporary things in the cache folder, and you put user data in the document directory. The first thing we do is we need to find out where the document directory is. We can't use just a hard-coded path. The operating system could just change where this is between iOS versions. So we use the file manager class, and like when we used the user defaults class, you can get the default instance of the file manager. Again, this is a singleton available by this default property. So you say file manager default, and it has a method called URLs for, and you specify what you want and in a domain. So in this case, we just say we want the user's document directory in the user domain, because you could talk about things at the user level or the system level. And this returns us an array of paths. We can just take the first one, and that'll be the user's document directory, and we can construct a URL, and we do that by taking the document directory and appending a path component. And as we do that, we say / whatever the file name is. So then we have a local URL that represents a file inside the user's document directory. The next part should be fairly familiar, the next 3 lines. This is just a normal Swift dictionary. Its type is, it has a key of type string and a value of type any. So any is our catch-all type. If we knew we were only storing, say, strings in there, this could be more specific and just be string. The part here after the assignment is just a dictionary literal. It's an empty dictionary. The next thing we do is we put a couple of things into this dictionary. So we can say dictionary, specify a key, and give a value. Obviously the type of this one is string, and the type of the second one here is an array of integers. Once we've done that, in order to write a dictionary to a URL, we can't use a normal Swift dictionary. We need to use an NS dictionary. So these next lines, the whole do catch part, is all about doing the write. Now, why does it need the do catch part? Because this write method of NS dictionary can throw an error, and that means we need to catch it. If you don't do this, the compiler will complain and say the write method can throw, you need to catch it. And the way we do this is we enclose it in a do catch block. Inside the do block here, we need to add a try keyword to anything that can throw. And that's good because it allows you to read the code and understand which parts of it can throw errors. And then we have the catch block. You can write specific catch blocks like if statements to catch different types of error, but we just have a catch-all here, which is basically like an else statement in some sense, like it catches every case. And there will always be an error variable defined in here that represents the error that was thrown. So the only part I haven't talked about here is this line here where we say let NS dictionary be equal to our dictionary. So dictionary is a Swift dictionary. NS dictionary is the Swift dictionary converted to NS dictionary. And we do that by just saying dictionary as and then giving the type NS dictionary. And because the types can be mapped between, that just converts it into the other type. So that's our example of saving data. If we want to read that same data back, so imagine we've got key 1 and key 2, one's a string, one's an array of integers. How do we do that? Well, we again need the exact same URL. So these first 3 lines are identical to the previous slide because we need to load that same property list, mydata.plist. And then what we do is we construct a new NS dictionary, and one of its initializers is called NS dictionary contents of, and you give a file URL, which is what we do here. So this part here allows us to load a new dictionary. Now, this can return nil, so it can fail, like if this URL doesn't exist or it can't be loaded as an NS dictionary, then this will return nil. So our let statement here is inside an if, and we're checking to see if it's nil. The other thing that we're doing as part of this creation, we're also casting it to a dictionary, a normal Swift dictionary, with the type string as the key and any as the value. And we're saying as with a question mark, so this is not a forced cast. It's an optional cast. So if it can't be cast to this, then this will return nil. So basically, there's a couple of reasons this could return nil. It could return nil because the dictionary fails to load. Okay, then it will just return nil. If the dictionary does load and it can't be cast to this type, it will also just return nil. And in either case, this if statement will fail, and then we could put an error case down here. But if it didn't fail, then that means that the dictionary loaded and it was of a dictionary type with a key string and a value any, and then we can just access these values. Look, accessing any value from a dictionary, as we saw with the movie example last week, if the key doesn't exist, you're going to get nil back. So again, we use this nil coalescing operator here because this part here can be nil, rather than it telling us that this is an optional and just printing the value. We check if it's got an actual value. If so, that gets printed. If not, we're printing a string key1 value not found. Okay, so that's property lists. Now, Codable is a sort of extension to this, or at least something that makes this a little bit neater for us. So this has existed a couple of years since Swift 4, and we can use Codable with property lists. Codable is something we'll revisit in future weeks, so it's really important to know it, and it's a very useful thing. So what is it? It's basically a protocol that allows us to encode and decode data easily. And that means we can take custom types of our own encode them and put them into some other file format like JSON or a property list. And then we can also read that same property list or JSON file and decode the data back and use it and have it as our instances of our original types. So that's super useful. So we'll look at the JSON example last week. For the moment, we're just doing it with property lists. So remember, our property list only supports simple data, so you must still have classes that only include those data types. So we looked at a person class before. This is a struct. So what is a struct? A struct is basically like a class, but without any methods. So it's just an object that holds some properties. Okay. The other thing that's really important to know about structs and where Swift behaves differently with them is when you assign a struct to a variable, so you say something like let var equals and then give it an instance of a person struct, you get a copy of it, and anything you change in that copy does not change the original. So that's what copy by value is. You end up with a copy of it. The copy by reference, which is what happens if you do this with a class, you end up with a reference to that class. And if you make a change via your variable, you're changing the original because it's a reference to the original. So there is some difference in behavior here that you need to be aware of. Anyway, let's have a look at our simple person struct. We say it's of type Codable. But this doesn't matter too much for this example, and we have two properties. That is, name is of type string and age is of type int. We do need this Codable annotation, which is just saying it inherits Codable. How can we use it? Well, to create a new person, we can do it like this. And in fact, we don't even need to define an initializer for the person class. You get a default one based on just the properties that are defined in it. So this code will work with the code from the previous slide. Again, we have the same 3 lines we had before. We need to have a URL to a property list in the user's document directory. But then this part's a bit different. So we've got our instance of our person struct. We create an encoder by instantiating property list encoder. We tell the encoder what format to output to because it can encode to a variety of different file formats, and you can have a look at the documentation to see this. We just specify .xml, and then we ask the encoder to encode our person class or person instance of the struct here, and give us back some data. And this type will just be a type called data. Now this can fail because it might not be possible to encode this to XML, in which case, it'll throw an error. So again, this is in a do catch block like we talked about before. Once we have the data just has a method called write where you can give it a URL and it will write some arbitrary data to a URL. And data could be anything. Data could be image data, and you could save it to an image in this way, an image file, or it could be XML data in this case that we're saving to an XML file. How do we load from a property list? It's the same 3 lines to get our URL, and then we create an instance of data, and it has an initializer with a parameter called contents of, where we can specify URL. Again, this can throw an error, so hence the try keyword. We get back some data. When we've got the data, we can create instantiate a property list decoder, and we tell the decoder the class that we want to decode into, and we give it the data, and it will give us back an instance of this structure in this case. I mean, this could be a class or it could be a structure. Codable works on both, so that's good to know. And then once we have the person, we could just try printing it and check that this works. Now, you can even do more complicated things, and when we use this in future weeks, you'll see that. So, for example, if we had, I don't know, an array of person structures, we could use an array of person here and specify its self property and decode into an array and get instead an array of things, if that's what our XML contained. Yeah, so that's Codable. Thanks for watching.